Hey guys, it's Miss Winger. I hope you guys are all staying safe and healthy. I miss you guys, and I'm excited to start learning in this new way, although I wish I could see you guys and interact and joke around like we always did, but that's okay. I'm still looking forward to connecting with you guys and continuing learning. We're starting off this week just with some review, as I'd mentioned in my earlier video on Google Classroom, just so you guys can get used to using the technology without having to learn new information. So this whole first week, we're going to be reviewing our exponent rules that we were learning before we left school in early March. So this first video, I'm going to review with you guys negative exponents and the zero rule, which kind of help lead and kickstart us with all of the other rules. So if you want, I would recommend just taking out a blank notebook paper or a lined piece of paper and a pencil and writing down some of these examples as we go through them. Just so that when you guys are doing some of the practice problems on your own, you have some stuff written down in your own handwriting that you can quickly reference back to instead of having to replay this video. There's a few times in this video where I will tell you to pause the video and try a few on their own, or try a few on your own. This is really important, so I wouldn't actually skip over that, although it's tempting just to let the video play and not actually do that. It's really helpful if you try it on your own and then have me to kind of check in with you after. So when I say pause the video, I really do want you to pause the video and try something on your own. That way you have an answer right after instead of trying it on your own for the first time when we do the practice problems. So let's get started. The first rule I want to review with you is this zero rule. This was the very first one we learned, and you may or may not have remembered it, but any non-zero number raised to the power of 0 will always equal 1. Okay, and I'm writing with my finger here, so you're going to have to excuse the fact that I'm going to be writing kind of slow and it's kind of sloppy, but we'll get through it. So the reason I say any non-zero number is because this does not work for 0. 0 to the 0 power is not going to be 1, but anything else will work. So, for instance, 5 to the 0 power, what does that equal? 1. Okay, x to the 0 power, 0. What does that equal? 1. Okay, things that will never equal, something like x or 0, these are wrong. These are not correct answers, and I know that's tempting, especially when we see variables like this one, to try and say that that equals 0, but it doesn't. It equals 1 just like everything else. So let's do a few practice problems with that. Oh, actually, I showed you guys this in class, why this is true. Let's go through this. So why is this true? Well, let's think of examples like 2 to the third power. What is 2 to the third power if we expand that out? It's 2 times 2 times 2, which equals 8. Okay? 2 squared, what is that? 2 times 2, which we know equals 4. 2 to the first, that would just be 2, times itself, which is obviously 2. And so let's look at these patterns. If we look at how did I get from 8 to 4, I divided by 2. How did I get from 4 to 2? I divided by 2. So looking at the pattern of these answers will help me come up with the next one down, which would be 2 to the 0. What would that equal? Well, let's just follow this pattern over here and divide by 2 one more time. And what will that equal? 2 divided by 2 equals 1. So the reason that anything to the 0 power is true really just comes from this pattern over here of continuing to divide by 2, and 2 divided by 2 gives us 1. Okay, we went through that in class a lot more slow, but I just wanted to remind you of why that's there, and so you don't just think it's this random rule that's made up. It actually just comes from dividing two numbers. Any number divided by itself equals 1, and that's why that works. Alright, so let's do some examples. 6.7 to the 0 power, surprise, surprise, that equals 1. Okay, the only time we have to be careful is when we start having negative numbers, like this example number 2. Negative 534 to the 0 power. Okay, we can think of this, since the negative is not included in the parentheses, you can think of this as really like a coefficient. This is negative 1 times 534 to the 0 power. Okay, again, sorry my handwriting is so bad on this. I'm using my finger, so it's a little bit harder. We know from our rule that this part, of course, is equal to 1. So that equals 1, the part that I boxed in green. However, we're still multiplying it by a negative 1 because that negative 1 was on the outside. So altogether, negative 1 times 1 equals negative 1. So again, the reason why this one ended up being a negative is because in this original problem, right here, the negative was not included in the parentheses. Okay, so let's look at the third one. The difference in this one is that the negative is included in the parentheses. So this part that I boxed in yellow, that's going to be equal to 1. Negative 7 in parentheses to the 0 power is 1. Because the negative is inside the parentheses, it's raised to the 0 power as well, it equals 1. So all we have left to do with this is still do the remaining part of the problem, which is multiply it by x to the 4th power. So I have 1 times x to the 4th power, which equals x to the 4th power, and that will be my final answer. Okay? Let's do the last one together. The part that's going to be 1 is this part right here, x to the 0 power. That part right there is going to be the number 1. Notice that the exponent of 0 is not going to the 4. It's just attached to the x. So just the part I circled in green is going to be 1. Everything else is still there. So we still have 5 x to the 3rd power times 4 times, and instead of writing x as 0, I'm just going to write 1. Okay, and let's put together what we can put together. Let's combine any like terms we can. We can multiply 5 times 4. I know that that equals 20. So now I have 20 x cubed times 1. And anything times itself is just itself. So really, there was no point in me writing that times 1. I could have just ended the problem right here. So 20x cubed is my final answer. Okay. Let's move on to negative exponents. This is the second rule of this video that I want to review with you guys. The rule here is that if you have negative exponents, and what I mean by that is something that looks like this, x to the negative 3. What the heck do we do with that? Well, you can rewrite them as positive exponents, and not that you can rewrite them, it's you should rewrite them. We should always take negative exponents and write them with a positive exponent all the time. Whenever we're simplifying things, we always want positive exponents. So you can do that by moving them to the opposite side of the fraction. Okay, so notice that this we can think about as technically over 1, and we could make that exponent positive by moving this whole thing to the opposite side. So if it was in the top, we're going to move it to the bottom. And so what this would look like is 1 over x to the positive 3. Okay, and so let me show you an example of what if we had something. So let me just do a little division, or a little divide my screen in half here. What if we had one that was already in the bottom, like this? I'll do negative 4 this time. Well, we can make it positive by taking this whole thing and moving it up to the top. So if it's in the top, you bring it to the bottom. If it's in the bottom, you bring it up to the top. If I bring it up to the top, there's nothing left in the bottom. So you could either write it as over 1, or you could just leave it as plain old x to the 4th. Okay? So, if you have negative exponents, you move them to the opposite side of the fraction, and that will make them positive. Why does that work? So think back to the what I just did with you with 0 exponents as to why anything to the 0 power is 1. I did this, where we said 2 to the 3rd is 2 times 2 times 2, and that's 8. 2 squared is 2 times 2, and that's 4. And we see this pattern of, oh, I just divide by 2 every time I'm lowering the exponent. So let's continue that. 2 to the 1st is 2. 2 to the 0 we know is 1. Just to check in and make sure that this dividing by 2 pattern is still happening, and it is. 4 divided by 2 is 2. 2 divided by 2 is 1. So we're still holding true with that pattern. Oops, I just erased a little bit too much. Let me rewrite that in there. Okay, so let's do negative exponents. So if I want to do 2 to the negative 1st power, well, I'm just going to do the same pattern of taking my answer and dividing by 2 again. So what's 1 divided by 2? 1/2. If I want to do it one further, I'm going to bring this up to the top. Let's do 2 to the negative 2 power. What do I do with my pattern? Take the previous answer, which is over here, I'm circling it in yellow, and divide it by 2. 1/2 divided by 2 is 1/4. Now notice we can write 1/4 as, that's the exact same thing as 1 over 2 squared, because 4 is the exact same thing as 2 squared. Okay, so I think this box over here really highlights this rule. If you have a negative exponent, you can make it positive by flipping it to the denominator. And really, the reason that this is true is for the same reason as why something to the first, or something to the 0 power is 1. It's just this pattern of continuing to divide by your base. Okay, let's do some examples. Okay, so I have in this first one 3 to the negative 3. So how can I make this exponent positive? I can do that by flipping it to the denominator. Okay, now sometimes I will actually have you evaluate what number that is if it's a pretty low answer, and sometimes I'll just have you leave it like this. 3 cubed, I think we can figure that out pretty easily. 3 cubed is 3 times 3 times 3, which is 27. So this is the exact same thing as 1 over 27. And that's how I'm going to write my answer to that first one. Okay? All right, let's do the next one. I have negative 2. Notice the negative is in parentheses, to the negative 4th power. So how can I make the exponent negative? Notice that's the only part of this that would not be a good way to leave it. It's okay that the base is a negative number. What we don't want is exponents that have negative numbers. So again, I'm going to do the same thing. This is in the numerator. I know it's in the numerator because there was no fraction bar, so there was nothing in the denominator, or you can think about it as being 1 in the denominator. And so I'm going to flip this and move this whole thing to the bottom. So it would be 1 over negative 2, still in parentheses, to the positive 4 power. So the only thing that changed is that negative 4 exponent became a positive 4 exponent in the denominator. And we can go ahead and figure out what that is equal to. So let's evaluate this part of it. Negative 2 times negative 2 times negative 2 times negative 2. That's what that means to do negative 2 in parentheses to the 4th power. So what is that? Well, negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. So I know that this is actually 1 over positive 16, and that's my final answer for the second one. At this point, I'm going to erase my screen so that I have more room to do the last two examples. So if you are still writing this down, pause your screen so that you have a second to get this written down. All right, let's do that third example. This one, the negative, is already in the bottom, so I can bring it up to the top and make that exponent positive. So this whole thing is just going to go up to the top, and it will be 4 to the positive 3rd power. I would not expect you to know this without a calculator, but you do have calculators with you, hopefully, and so we can figure that out. 4 times 4 times 4 is 64. So I can write this as 64 and use that as my final answer instead of leaving it as 4 cubed. That again would be one that if this were like on a test or a quiz would be on a calculator section, and I would not expect you to know that. Okay, I love this last one, and I'm gonna erase my work again, so if you need, go ahead and pause the video right now so that you can copy that third one down because I'm going to erase it. I love the last one because it actually involves several of our exponent rules that we just reviewed. So what I'm noticing right away, 5 to the 0, that's just the number 1. So that makes it easy for us to get this problem started. So I'm going to rewrite 5 to the 0 as 1 and then go from there. Second rule I see is that I have a negative exponent. How can I make that positive? By moving that whole thing up to the numerator. And that leaves me with 2 squared over, and all the stuff I had just circled in green right here, if all that's moved to the numerator, there's nothing left in the denominator. So you can either write 1 or you can choose to leave it as 2 squared. Now we of course know that 2 squared is equal to 4 I'm running out of space here, so I'm not going to write that, but you can just write that answer as 4. All right, awesome. Let's do some more examples. This is going to be my last page. On this page, I'm going to have you pause the video and try a few on your own. I think I want to go through some of the ones that involve more rules, like ones like this, and have you try some of the easier ones on your own. So right now, I want you guys to do this first one that I just boxed in, x to the negative 6. I want you to pause the video and rewrite that, simplify it on your own, and then I will write the final answer up here. But pause the video, and when you're ready, hit play again so that you can see the final answer. Okay, so hopefully you got what I got. I moved the exponent of negative 6 down to the bottom, and it's 1 over x to the positive 6. All right, let's do the second one together, because what I could see, if some of you maybe worked ahead, is I could see some of you writing it like this. And I'll tell you now, that's actually incorrect. This is not the correct answer. So let's go through this one together and see why that's wrong. And the reason that will really help us out with this one is to ask ourselves the question of what base is the exponent attached to? Is it attached to the m, or is it attached to the 3, or is it attached to both? The answer is that that exponent of negative 2 is only attached to the m. It is not attached to the 3. If it was attached to both, it would have been written like this, and I would have known that the negative 2 exponent is going to both. It was not written like that, so I know that it's only attached to the m, which means the part that will get flipped is just the m. So the 3 stays in the numerator because there's nothing weird with that, no exponents attached, and the only thing that gets flipped to the denominator is the m squared, and I'll leave it just like that. Okay, and so now this time I want you to pause the video again, and I want you to try this third one. A to the negative 2, b to the negative 3. Both of those have negative exponents, and both of them will need flipped. So pause the video, write that out on your own, hit play when you're ready to check your answer. Okay, so here's my final answer. Both variables needed to get flipped because both variables had a negative exponent. And so there's my final answer boxed in. All right, I'll go ahead and do the fourth one with you. What I want to point out is the only thing that has some issues is the y term. It's the only one that has a negative exponent. What that means is the x to the 5 can stay put, and the only one that will get flipped is the y term. So it's nice and easy, pretty quick. Just flip the y squared to the bottom. All right. Second to last one, I'm going to do with you, this one right here. And then as the final one, I'll have you do this one, the very last one I just boxed in green on your own to double check that you understand everything from today's lesson. It really puts it all together. So let's work through this second to last one. First thing I notice is anytime I see a 0 exponent, I want to write that as the number 1 right off the bat to make my life easier and to make this problem just more simple right away. So writing 2 to the 0 as 1 gives me this, what I just wrote out, as a step 1. Now 1 times x squared is just x squared. So I really didn't need to write that as 1 times x squared. I just wanted to write that out to show you guys the rule. Okay, now what's the other issue with this problem is that there's a negative exponent right here. The x squared in the top, this one right here, there's nothing wrong with that. So I'm going to leave that put and just move the y to the negative second. I'm going to move this up, and that's the only thing I'm going to do. If I move it up, I have 1 times x squared times y squared. And I don't need to write the 1 times, so I can just write that as x squared, y squared. And that will be my final answer. Okay, my screen's starting to get overloaded with ink. I'm going to pause my video and erase the screen and have you guys try the last one on your own. So right now, pause the video on your own and do the very last one, and I will write my answer up for you guys. Okay, so my final answer is 4y cubed, what I boxed in at the bottom. The reason I got that is because this x to the 0 is really just the number 1, and y to the negative 3rd power I brought up, and that is why there was actually nothing left in the denominator. If you wrote your answer like this over 1, that is totally fine, just not necessary. So I usually like to leave my things looking as simplified as possible, And so if there's a denominator of 1, I usually just don't write a denominator at all. All right, that's the end of this lesson, you guys. I'll be posting another video. Actually, it's already posted, but for you guys to watch later this week. Hopefully this was a good review into what we were learning back in early March when we were working through these. I miss you guys. I hope you're doing okay. Remember to pop in during office hours if you have any questions for me. I'd be happy to go through this with you again, and just make sure you guys are doing well. Stay safe, stay healthy. Miss you guys. Have a great week.